Suppose the water tank is not cylindrical, but spherical, with a cross-sectional area A at height h. The volume of water in this tank would be an integral of A from 0 to h meters. The fundamental theorem of calculus gives that dV over dt is equal to A of h. We can rewrite the dV over dt as dV over dh multiplied by dh over dt. Therefore, substituting dV over dh for A of h, we get that dV over dt equals A of h times dh over dt. Going back to the beginning, we know that Torricelli law states that dV over dt is negative value of area of the hole multiplied by square root of 2gh. Thus, we can replace dV over dt with Torricelli law formula to get the equation where cross-sectional area at h times by dh over dt equals to negative 8 times square root of 2gh. Suppose the radius of the spherical tank, uppercase R, is 2 meters, and that it is initially half full of water. Thus, the initial height of water equals to the radius, or 2 meters. Let the area of the circular hole be 1 centimeter, 0.01 meter. For this question, we take the value g to be 10 meters per second squared. To derive formula of dh over dt in terms of h, we can do the following. Let's take a closer look at our two-dimensional diagram of the tank. The distance between the center of the circle and the water level can be written as difference between radius and the value of the height of water, r minus h. Let's label the distance between the border of the water level and the point on the water surface right below the center of the circle to be lowercase r. The distance between the border of the water level and the center of the circle is equal to the uppercase r of the circle. Looking at the side uppercase r minus h, lowercase r, and uppercase r, we can see how they form a right triangle. From here, basing on the Pythagoras theorem, which states that the square of the hypotenuse side is equal to the sum of squares of the other two sides, we get an expression r minus h squared plus lower r squared equals to the square of uppercase r. Since the value of uppercase r is constant, we substitute it with the value of 2 and derive the formula of lowercase r squared in terms of h. Knowing the relationship between the radius of the surface area and the height of water, we can rewrite the formula of surface area of h the following way. After simplifying the equation for surface area, we input it into our previously updated equation of Torricelli law. Replacing all the known components with their numerical value, we can derive the formula of dh over dt in terms of h. Now, in order to answer the question how long it will take for the water to drain completely, we derive the formula of h in terms of t by separating the variables of the equation dh over dt. To find the value of the constant c, we use the initial condition that the tank was half full in the beginning. Thus, h at time 0 seconds is 2 meters. We input these values into our formula and solve for c to get a value of 1.18. When the tank is empty, the water height is equal to 0 meters. We substitute the h for 0 and solve for t. Completing all the calculations, we get that it takes 11,800 seconds or 3.28 hours for the spherical tank to drain completely.